Let's start with something most people rarely question. When you flip a switch, the lights turn on. Every time. Day or night. Summer or winter. That level of consistency has shaped how we think about electricity. It feels permanent, reliable, almost guaranteed. But here's the uncomfortable truth. That reliability depends on a system that is becoming more complex, more strained, and in some ways, more fragile than it used to be. Not broken, not failing, but carrying more pressure than ever before. And today, we're going to walk through why depending entirely on the grid is becoming riskier, not in theory, but in practical, everyday terms. The grid was built for a different time. The modern power grid in the United States was designed decades ago. At the time, electricity demand looked very different. Fewer electronic devices, less reliance on continuous power, more predictable usage patterns. Homes used electricity for lighting, basic appliances, and some heating or cooling. Today, that's changed. We rely on electricity for almost everything: work, communication, food storage, climate control, security systems. And that demand isn't just higher, it's constant. Which means the grid is now supporting a lifestyle it wasn't originally designed to handle at this scale. Demand is increasing faster than infrastructure. Electric vehicles are becoming more common. Homes are adding more devices. Heating systems are shifting toward electric. Cooling demands are rising with higher temperatures in many regions. All of this increases the load on the grid. But infrastructure upgrades don't happen overnight. Transmission lines, substations, and transformers take years to plan, approve, and build. So in many areas, demand is growing faster than the system can comfortably expand. That doesn't mean failure is constant, but it does mean the margin for error is getting smaller. Extreme weather is becoming a bigger factor. Weather has always affected the grid, but in recent years, extreme weather events have become more frequent and more intense. Heat waves push demand to peak levels. Winter storms damage infrastructure. Wildfires force preventive shutdowns. Hurricanes disrupt entire regions. Each of these events adds stress to the system. And when multiple stress factors overlap, high demand and extreme weather, for example, the risk of outages increases. Not because the system is poorly designed, but because it's operating closer to its limits. The grid requires perfect balance. One of the least understood aspects of the power grid is this: it must maintain balance at all times. Electricity supply and demand have to match in real time, every second. If demand spikes suddenly, supply must increase immediately. If supply drops, demand must be reduced just as quickly. There's very little room for delay. And when that balance is disrupted, protective systems can shut down parts of the grid to prevent larger failures. From the outside, that looks like a sudden outage. But from the system's perspective, it's a safety response. Centralization creates dependency. The grid is a centralized system. Power is generated in large facilities and distributed across wide areas. This allows for efficiency and scale. But it also creates dependency. If a key part of the system is disrupted, whether it's generation, transmission, or distribution, large numbers of homes can be affected at once. And because everything is interconnected, local issues can sometimes have wider impacts. For the individual household, this means one thing: you're connected to a system you don't control. Pricing is becoming less predictable. It's not just reliability that's changing. Cost structures are evolving too. Utilities are introducing time-of-use pricing. Rates fluctuate based on demand. Peak hours become more expensive. Even if your total electricity usage stays the same or decreases, your bill can still increase depending on when you use energy. So dependence on the grid isn't just about access, it's about exposure. Exposure to pricing changes, policy changes, demand shifts, and those factors are becoming more dynamic over time. The illusion of stability. Because the grid works most of the time, it creates a sense of certainty. You don't think about it, you don't plan around it, it's just there until it isn't. And when it goes down, even temporarily, the impact is immediate. No lighting, no refrigeration, limited communication. What feels like a minor inconvenience at first can quickly become a practical problem, especially if the outage lasts longer than expected. Why short outages still matter? Some people hear all this and think, outages don't happen often where I live. And that may be true, but the frequency of outages isn't the only factor. Duration matters too. A short outage is inconvenient. A multi-day outage changes how a household functions. Food storage becomes an issue. Temperature control becomes a concern. Communication becomes limited. And those scenarios don't require a complete system failure, just a temporary disruption. The real risk isn't catastrophic, it's practical. This is where the conversation becomes more grounded. The risk isn't that the entire grid disappears. The risk is smaller, more practical, temporary outages, rising costs, reduced predictability. And when a household depends entirely on one system, even small disruptions have a bigger impact. A shift in thinking. So what are people starting to do differently? They're not abandoning the grid. That's not realistic for most homes. But they are rethinking dependency. Instead of relying on one system for everything, they're exploring ways to add stability. Not total independence, just enough to maintain essential functions when the main system is unavailable. What stability actually means. Stability doesn't require powering an entire house. It means keeping the basics running. Refrigeration, lighting, communication devices. Those systems define whether an outage is manageable or disruptive. And maintaining them doesn't require massive energy production. It requires consistency, reliability, efficiency. From reaction to preparation. Most people think about outages after they happen. When the lights go out, then the questions start. What should we do? How long will this last? What do we need? But a small shift happens when you think about it ahead of time. Not in a dramatic way. Just a practical one. What would we need to keep running? What's actually essential? Once you answer those questions, the path forward becomes clearer. The real takeaway. Depending on the grid isn't a mistake. It's how modern life works. But depending on it completely, without any backup or flexibility, is where the risk comes in. Not because the grid is unreliable, but because it's a complex system with variables outside your control. And understanding that is what allows you to make better decisions. On this channel, we break these ideas down step by step. No fear-based messaging. No unrealistic solutions. Just clear, practical insights into how energy systems work and how households can adapt to them. In upcoming videos, we'll explore why electric bills keep rising even with lower usage, what actually happens during extended outages, where common backup solutions fall short, and how some households are building more stability into their energy use. If this kind of thinking is useful to you, subscribe to the channel. And if you want to explore practical approaches people are using to reduce total dependency on the grid and keep essential power available when it matters most, there's a resource linked in the description. You'll also find it in the first pinned comment. It connects directly to what we discussed today. Understanding the limits of the grid and what you can realistically do about it. Subscribe, check the link in the description or the pinned comment, and I'll see you in the next video.